In this presentation, we explore bitmap images. Images can be represented using vector or bitmap graphics. In vector graphics, shapes such as lines, points, and polygons are used to represent images. Complex shapes can be constructed from these basic primitive shapes. Bitmap images are made up from tiny dots called pixels. Each pixel will have a color associated with it. An image that can then be constructed from many of the pixels, which will have different colors arranged in rows and columns. Vector graphics are scalable, whereas the quality of bitmap images can degrade when the image is overstretched. Vector graphics are good for images with limited colors, such as cartoons or logos. Bitmap graphics are better for representing more complex scenes with a huge variety of colors, such as photographs. The size of a bitmap image depends on its height and its width, and the total number of pixels in an image are the number of pixels in height times by the number of pixels in width. The color depth is the number of bits used to represent each pixel in an image. If we have a black and white image, it has two colors. Each pixel can be represented by a single bit because it's either 0 or 1. To represent more colors, we need to use more bits. For instance, if we have 2 bits, we can represent 4 colors because we now have 4 different combinations: 0, 0, 0, 1, 1, 0, 1, 1, and each of those can represent a different color. If we want to have 8 grayscale colors between black and white, we'll need 3 bits per pixel. So with 8 bits, we can represent 256 different shades of grey. With 24 bits, we can represent red, green, and blue with 8 bits for each colour. Every colour can be represented as some combination of the red, green, and blue at different intensities. This means that we can represent roughly 16 million colours. For most situations, this is sufficient, as the eye can't discern that number of colours anyway. Image resolution is an important factor, and it represents the number of pixels per area of image and is often given in dots per inch. The more pixels, the better the quality of the image. Lower resolution images can be pixelated, as you can see with the one on the left here. It's clearly blurred in places, whereas the one on the right hand side is much clearer and crisper. Pixelation occurs when the image is overstretched. In these situations, the image has a blocky and blurred appearance. This arises when the image is presented at too large a scale and there are not enough pixels to reproduce the detail in the image at this larger size. We can encode our image, our black and white image here, as zeros and ones. So 0 is encoded as a black pixel, white is encoded as 1, and we'll encode these 25 pixels that are in this image as zeros and ones, as you can see at the bottom of the slide here. So 0, 1 representing the 3 blocks of white pixels at the top here, followed by a 0, so that represents the first line, and it's just simply a long string of digits of zeros and ones.